are going presenting about application of crystallization. So, what is crystallization? Crystallization is the process by which a solid forms from a liquid or gas where the atoms or molecule arrange themselves into a highly ordered structure known as crystal lattice. This transformation typically occurs where a solution becomes supersaturated, meaning it holds more dissolved material than it can normally contain, and the excess material begins to solidify in a structure patterns. Did you know that there are three stages of crystallization? So, the first one is mucosation. This is the beginning where tiny solid pieces called seeds start to form in the liquid, and crystal growth, where the tiny seeds grow bigger as more beads from the liquid stick to them. And the lastly is aggregation, where some crystals stick together in small groups, but each crystal keeps its shape.
As we all know, crystallization is a process in which the liquid turns to solid form. The theory of crystallization is based on these two elements, which is the driving force, which is the supersaturation, and factors that influence the crystallization. Therefore, what is supersaturation? Supersaturation is a solution that is unstable. If the solution is disturbed by introducing a sick crystal or a change in the temperature, they can rapidly crash, causing the excess solute to precipitate out of the solution and form crystals. Supersaturation occurs within these two conditions, which is when it is cooling and evaporation. Therefore, there are four driving forces in crystallization, which is cooling, evaporation, chemical reaction, which is reactive crystallization, and adding an anti-solvent. As for cooling, cooling is a saturated hot solution will lead to supersaturation. As for evaporation, the concentration of the solute increases after removing the solvent, resulting to supersaturation. The next one is chemical reaction. Chemical reaction is a reactive crystallization. Chemical reaction will produce new compounds that have low solubility in the mixture, resulting in crystallization. And then we need to add an anti-solvent. By adding an anti-solvent during crystallization, it is a technique that is often used to induce the formation of crystals by altering the solubility of a compound in a solution. The process is commonly referred to as an anti-solvent crystallization or precipitation. The next one is factors that influence the crystallization. There are 5 factors of crystallization, which is supersaturation level. Next is temperature, then impurities. Next is solvent properties and cooling rate.
Next, we move on to methodology or procedure of crystallization process. Step 1. The impure solid is added to a suitable solvent and heated gently. Heatings help the solid to dissolve more easily, forming a saturated solution. Insoluble impurities may be removed by filtration. Step 2. The hot solution is heated further to evaporate some of the solvent. This increases the concentration of the solute, creating a supersaturated solution that is ready to form crystal upon cooling. Step 3. The concentrated solution is allowed to cool slowly. As the temperature drops, the solute becomes less soluble and form pure, solid crystals. Most impurities they dissolve in the leftover solution. And the last step, the remaining liquid or known as mother liquor, is poured off or filtered out. The crystals are then dried using filter paper or air drying, leaving purified solid crystals.
For the types of crystallization, first we have cooling crystallization. This method relies on lowering the temperature of a solution to reduce the solubility of the solute. As the solution cools, the solute becomes less soluble and begins to crystallize out. This technique is energy efficient and commonly used for heat-sensitive materials. Involve a chemical reaction where the product is less soluble in the solvent than the reactant. The newly formed insoluble product then crystallizes out of the solution. Reactive crystallization is particularly useful in the pharmaceutical industry and for purifying substances. Lastly, we have evaporative crystallization. In this method, the solvent is evaporated from the solution, increasing the concentration of the solute. As the concentration increases, the solution becomes supersaturated and crystals start to form. Evaporative crystallization is often used in industrial processes such as the production of salt and other solid compounds.
Now, I will explain about the examples of crystallization process. First, we have purification of table salt, or known as sodium chloride. It is crystallized from seawater or salt mine. It is used in cooking and also food preservation. Secondly, we have sugar crystals, or known as sucrose. It is crystallized from sugarcane or sugar beet juice. It is used as sweetener in food and also drinks. Thirdly, we have copper 2 sulfate crystals. It is formed by crystallizing a solution of copper sulfate. It is used in chemistry experiments and agriculture as a fungicide.
In conclusion, crystallization is an important technique used to purify solid substances from solution. It plays a key role in industries such as pharmaceuticals, food, and chemicals where high purity is needed. By carefully controlling temperature and concentration, crystallization allows the formation of solid crystals with fewer impurities. This method is not only useful in laboratory experiments but also widely applied in large-scale production, making it a valuable tool in both science and industry.